Hello everyone, my name is Dan the Tutor. Today we're going to be covering systems of equations. Now the first thing I want to say about systems of equations is there's two ways of solving systems of equations. Number one is using the elimination method, and two is using the substitution method. I'm eventually going to be going over both. Today I'm going over elimination though, and in the next video I'll be covering the same thing but with substitution. So first let's talk about what this will look like when we do it correctly. The correct thing that it will look like is you have something like 3x minus 4y equals some number, and then you have negative 3x plus, let's say, 6y equals some number. And it doesn't matter what the numbers are. I can say like 1 and 0 here. But the goal is the fact that this is our systems of equations, and I see that if I add them up together, as is right now, 3x minus 3x is 0, negative 4y plus 6y is 2y, and then 1 plus 0 is 1, and you can divide both sides by 2 and get y equals 1/2. This is the basic premise. So the goal is to get one of our variables to cancel out, just like that. And if they don't cancel out, then I have to change one of the equations so that they can cancel each other out. So let's look at a full example now. Let's say I have 3x plus 4y equals negative 5, and my second equation is 2x minus 4y equals 10. So once again, we're already in the form that we want. This is great. So all I need to do is add the two together right now, and that's going to cancel out the 4y's here. 3x plus 2x is 5x, 4y minus 4y, like we said, is 0, and then negative 5 plus 10 is positive 5. Once we get to 5x equals 5, just divide both sides by 5, x equals 1. There's one of our answers. Now to find the y value, you need to plug in this answer, x equals 1, into your choice. You can either choose the top function or you can choose the bottom function. It doesn't matter, you will get the same answer either way. I will choose the top function because I think it might be a little easier. So what I'm saying is 3x plus 4y equals negative 5, and I'm plugging x equals 1 right there for that x. So in other words, 3 parenthesis 1, so multiplication, plus 4y equals negative 5. That means I'm getting 3 plus 4y equals negative 5. At this point, it's just simple linear algebra to solve for the y. I subtract 3, so 4y equals negative 8, and then divide both sides by 4, and I get y equals negative 2. So my total solution is x equals 1, y equals negative 2, or if you'd like to write that as a coordinate point, we could say 1 comma negative 2 as well. All of these are acceptable. So that's the easy kind of problem. Now with the next couple we'll look at, they will be harder. Let's say for the next one, I have x minus 7y equals negative 29, and for the second equation, negative 3x plus 2y equals negative 8. Now as we can see here, if you add these up together, nothing cancels. The x doesn't cancel, the y doesn't cancel. So there's nothing we can do, and we can give up. Thank you all for watching. This is the end of the video. No, I'm just kidding. We can solve this, but the first thing we need to do is we need to multiply one of these equations, or both of these equations sometimes, so that they do cancel each other out. So, for instance, I see here that if I multiply this top equation, if I multiply everything by 3, then that's going to get me positive 3x, which will cancel out with my negative 3x. So what I'm saying is, let me rewrite the equation right here. I'm distributing 3 to everything. So that's going to give me 3x minus 21y equals 3 times 29. That's 60 plus 27, negative 87. And if you can't do that in your head, you can either use your calculator or write it out the long way, like this. But once you get here, then you just rewrite the second equation directly below it. And once again, we're going to add these equations together. This time, the 3x and the negative 3x cancel. Negative 21y plus 2y is minus 19y. And negative 87 minus 8 is negative 95. Then all you need to do is divide both sides by negative 19. And that one I would recommend plugging in your calculator. And you'll get y equals 5. So there, we have one of our answers, y equals 5. Now for solving for x, there's 3 equations I can plug into. Let me show you. The first equation you can plug into is the original first one. The second equation is the original second one. And the third equation is the first equation, but we multiplied it by 3. All 3 of these will work. So it doesn't matter which one you plug back into. This time, I'll choose the second equation just to prove that you can use any equation to solve. So that's saying negative 3x plus 2y equals negative 8. And I am plugging in y equals 5 for y. That's going to look like negative 3x plus 2 times 5 equals negative 8. Simplifying, I get negative 3x plus 10 equals negative 8. Subtract 10 from both sides. Negative 3x equals negative 18. And then divide both sides by negative 3. And we'll get x equals 6. So once again, if you want to write it as a coordinate point, you can write 6 comma 5 because y was equal to 5. And that's a perfectly acceptable answer as well, depending on what your teacher wants. So again, if I scroll up to the original problem, originally we had this, and the trick was that the x's didn't cancel out yet, so you had to multiply the top equation by 3. Now, alternatively, if you wanted to cancel out the y's, you would have to multiply the top equation by 2 and the bottom equation by 7. Because when you do this, you would get the y's to cancel out. And if you don't believe me, go ahead and try this on your own. And if the y's don't cancel out, it means you made a mistake somewhere. But we're not going to do that. We're going to move on to the last problem I have to show you guys today. And that is 4x plus 9y equals 12 and 5x minus 12y equals 15. So once again, nothing cancels immediately. And I also see this time that there's no easy choice to multiply the top or the bottom. And that's because you're not going to multiply the top or the bottom. You're going to multiply both the top and the bottom. The real question you have to ask yourself is which one would you like to cancel out? If you'd like to cancel out the x's, for instance, then you need to multiply the top one by 5 and the bottom one by 4. And if you want to cancel out the y's, then you need to multiply the top one by 12 and the bottom one by 9. So I think canceling out the x's will be easier, so that's what I'm going to try to do right now. So I multiply the top one by 5, and I'm going to multiply the bottom not by 4, but by negative 4, and let's see what happens when I do that. So first, distributing the 5 to every term in the top, I'm going to get 20x plus 5 times 9 is 45y equals 5 times 12 is 60. And then distributing the negative 4 to every term in the second equation, that's going to give us negative 20x. Now maybe you see y multiplied by negative 4. And then negative 4 times negative 12 is plus 48y. And negative 4 times 15 is negative 60. So here it looks like the x's cancel. 45 plus 48 is 93y. And 60 minus 60 is 0. So now we're looking at 93y equals 0. And I know what you're thinking right now. You're thinking either it's no solution or infinitely many solutions because you've heard of that before. But that is not true, because we can solve for y here by dividing both sides by 93, and we'll get y equals 0, not the other two things I just said. And so then if I wanted to solve for x, I can either plug back into the original first equation or the original second. I'll choose the first one. So 4x plus 9y equals 12. Y is 0. So 4x plus 9 times 0 equals 12. That means 4x equals 12. And dividing both sides by 4, x equals 3. So my coordinate point I could write is 3, 0. And that's the answer for this one. But I do want to address that many of you are thinking now, well, I definitely remember seeing infinitely many solutions and no solution. Here's what that looks like. Here's what the problem would look like. Let's say I have x plus 2y equals 6 and 2x plus 4y equals 12. Now, first of all, I can't add these two directly right now, so I need to multiply the top one by not 2, but negative 2, because that's going to get it to cancel out. I distribute that to all three terms. Negative 2x minus 4y equals negative 12. And now I have 2x plus 4y equals positive 12. In this scenario, I will get infinitely many solutions because the x's cancel for 0, the y's cancel for 0, and on the right side, I have 0 again. And since 0 equals 0, this is true. There's nothing I can do about this. This is when I get infinitely many solutions. And all that means is that there are multiple numbers for x and y that will solve both of these equations. And remember, the last example was not like this because it was 93y equals 0, and I had that y in there. That's why it wasn't infinitely many solutions, and it also was not no solution either. And then for the scenario where we get no solution, that would be something like this. 2x minus 2y equals 9, and 6x minus 6y equals 7. For this one, I'd multiply the top equation by -3 to all three terms. That would give me -6x plus 6y equals -27. And then the second equation stays the same, like that. And then when I add these two together, I get 0x plus 0y equals -27 plus 7 is -20. 0 does not equal -20. This is when you get no solution. So now you've seen every combination you can possibly see for systems of equations, or if there's any I'm forgetting, please comment in the video below. Thank you all for watching, and in the next video I'm going to cover how to do this exact same thing, solving systems of equations, except using the method of substitution. Stay tuned for that. Have a great day everyone, and I'll see you in the next video. Bye bye.